Hi everyone, and welcome to Inside Unreal, a weekly show where we learn, explore, and celebrate everything unreal. I'm your host, Victor Broden, and in the studio today, I have Mr. Alan Willard. Willard, not Villard.
You can say Willard.
Can I?
You can.
Villard.
I won't answer to it, but you can say it.
All right. Our senior DevRel tech artist here on the team. You've been on the stream before.
I have.
Many a times, once with me. We did the touch input stream.
Input,
Yep, talking a little bit about, had a special
and
setup.
luckily, that is not what we're doing today.
No.
I've been doing a lot of touch stuff lately. It's nice to do something a little different.
Yes, today we are going through Cascade to Niagara.
Yep. So I've built a couple of particle systems in both systems, so I can kind of break down, talk about what I did in Cascade, and then how I did this same similar thing in Niagara. So if you're ready, we can go ahead.
We're ready. Floor is yours.
So I've got a project open that's got a very small amount of content, a little bit of Cascade and Niagara, and I rebuilt this, what's essentially a fusion bolt, like something you'd see in Unreal Tournament. If it flies around, it leaves behind a trail of particles behind, and if I open it up, you can see what it looks like. So I have a number of sub-emitters that build up the final look. Like here's the lead sparks, and then the ones that trail behind, and then the actual core of the thing, and then the kind of shiny sparkles. And all of these were built in a few minutes using existing materials. There's nothing particularly complicated in any of the particle systems. You can see they spawn, they have partially local space on the main body so that when I do drag it around, they stay together, and then obviously the trailing bits do not have local space, so they get left behind in the world. I've also got around it the other parts you would need, like the impact here and the muzzle flash. So kind of got all the parts you'd need to pick up the gun, shoot it, and have the particle effect fly out and hit something.
What's the shortcut for resetting them?
Or question mark. I think of it oddly as shift/,
okay,
which would be question mark.
Yeah.
But yeah, that'll cause all your particle systems in the scene to reinitialize. So if you need to test something,
Tip
you've got
of the day.
There you go. So yeah, if you've got a few things you want to see what they look like, you can do that really quickly. So going back into the main bolt, it's really pretty simple. The sparks at the head give it kind of the I'm blistering with energy. The trails behind it give it that little bit of length, so life, and then the rest of it is just to fill it out, and like I said, give it that really hot, bright spark. So going over into my Niagara folder, I have what looks to be pretty similar. You can already see some of the trails behind it. But this one was built using Niagara. So just looking at it visually, they're really, really close to parity. I try to make them fairly close. They're not quite perfect, but that's fine. Niagara's got a little more capability in it. So just looking at it here, this is Niagara. Looking at the overview, I can see each of these stacks equates to the same sub-emitters that I had in Cascade. So I've got, for example, the turn off these parts. I've got the main body of the bolt. It has secondary bolts that come off of it. So you can see we're already pretty much building the same parts. The difference is on Niagara, this is actually spawning new particles as the initials die. So instead of it being two completely separate systems, one is actually causing the other one to spawn. And then there's a bunch more about that that's being done in here. And so we'll talk a bit about that. Now, the biggest advantage to working with Niagara is that I didn't have to build each one of these sub-emitters from scratch every time. I can build one and then just add that to my list of emitters. So if I just want to add an emitter, I've got all these options here. If I just pick one like, let's see, just a foot puff. And I'll turn off the other ones really quick.
Is there a similar shortcut to solo?
There is, I just don't remember what it is.
Okay.
I'm literally going through because I don't. So this foot puff here isn't actually spawning any visible particles. There we are. Hey, it's not doing what I expected. How awesome.
Just another day at the office.
Yeah, it's not that unusual. Let me go ahead and get rid of this and turn these back on. Yay. So when I select one of these, I can go into its sub-properties. And by default, it has whatever I built when I built the original emitter. But then I can start changing these values. So, for example, the lifetime of this particular particle here is driven inside of the particle spawn. So it initializes the particle, and then it has all these kind of built-in values. And normally I would just set them. Or in Cascade, I would go into a distribution and say, you are a min-max or something like that. And we have a lot of those similar things in Niagara, but we have quite a few more. Okay. So you can go in and say, if I just want a range, I can use a uniform range between. If I want a random, I can do a random float. I can do all sorts of stuff. In this case, I'm using a range which is min-max, somewhere between these two values. But we can also do things like share values from other places. So I can go in and look at link inputs and say, okay, this emitter's age, I could use that age to determine how long its particles spawn. So if I say I want them to be less likely to live longer, I can say as the age increases, your lifetime gets shorter. So particles spawned late in the process will die very quickly, but ones spawned early might live longer, so you can have more complex systems. Then we also have the ability to determine what type of emitter spawn. So in this case, I'm spawning a CPU system that is driving all of what you're seeing here. And then we can also do GPU and as well as other things. Now, the cool part is, in Cascade, I had to have a sub-emitter for each thing. If I wanted two particles, like a sprite of one type and another, I could do that in that multiple sub-emitters. But for Niagara, we have the option of having multiple renderers.
Okay.
So I can have, say, complex simulation that has two different types of sprites, or a sprite and a mesh, or whatever. And this is where we start getting into the much more exciting things that Niagara can do over Cascade, in that I'm now looking at this particle system as a complete simulation. And then I'm deciding what data I want to use inside of that. So it's very easy to just say, when you render, let me add another sprite renderer. And so this one uses the default sprite material, which, well, if I had it open, it's really very simple. It's just doing a dot with a particle color and then has fall-offs for that. So here we can change and do a completely different material. Let's say this little flame mat, and I can just add that right here. And I will immediately start getting those additional sprites if I kill the other. Isolate. There we go. I found it. There. So now the reason I have these crosses instead of sparks is because this secondary emitter is already in there. It immediately gets the second sprite. Now, of course, because the color is being applied, it's overblowing that. So if we go into color, you can see I've got a nice gradient selection here. I can start just changing it. And we go back to more white. So now we have orange because the base material for the second sprite that's being created by the same system, right? I have one system that's creating all this complex simulation detail, and then I can choose on top of that how I want to render those things. And of course I could change to velocity, and now they kind of overlap or line, and you can see the crosses again. So that's how we can kind of start with a similar behavior and start to layer things on. Now, I can get rid of the
Is that where the option was? I saw isolate.
Yeah, there's isolate down here. And you can actually see the trails here down here it actually shows you each of the sprite renderers.
Okay.
So I can go right to it. I've already got it selected. But I'm in this particular sub-emitter, which you won't see here because it is the one that does the trails. So I might have actually broken into this. I'll grab that fusion bolt again. Oh, yeah, broke the trails. Let's see if I can fix those. Not that I remember touching this. I'm not going to worry about this too much. Oh, because it was still set to isolate. There we go.
And that applied.
That's the isolation.
And
so in here, if I click on the person, that will isolate just to that one. I knew there was a shortcut for it. So again, here's the little sparks at the beginning and the different parts.
And was that propagated to the viewport as well? Okay.
Yep, it immediately works. So when I go like this,
that's great.
You can see. So you can have it placed in the world, and because you can add externalized properties to that, like say I can make it so that the color is something that the user can edit when they drop it in the world, I can see that update on all of my children, not just the one that I'm working on. Because every time I make, I can inherit this behavior and have that shared between all of them. So the biggest difference between Cascade and Niagara, other than the base interface itself, is the ability to really quickly create things like scripts and modify properties really easily. So for example, I've got this little team object that I created, and when I drop it in the world, it just does this little burst. So there. If I select it and duplicate it, I now have two of the little bursts. But I've created this override parameter that lets me say, which team am I on? And by selecting that, I can really easily just say which color I'm going to be. Now, that's not a core functionality of Niagara. That's a little module that I wrote. So going into this particular sub-emitter, you can see I created this FXM team select. Got my window off here. So if I look at that, this is actually a little script that I wrote inside of Niagara. So I can say, given whatever the particle is doing at this point, I can get those behaviors, read them, make conditions. In this case, I'm converting them into colors. And then I'm saying, based on whatever this flag is, use A or B as the color. And then here's the coercion that allows me to do the, I think I've opened my, there. So because of the modules that I used in here, like these team colors and the ability to scale, the system already knows how to present those to the user as a really nice interface. So I've got a checkbox that selects between these two. I've got my full color picker. So if I change my Team 2 color, you can already see it changing in the preview. As I drag that around, it immediately updates. Everything goes as I drag things, as I make changes, I see and preview them immediately. So while the iteration time in Cascade is really good, the iteration time in Niagara is way better. And the fact that I can really quickly say, if I wanted to create an all-new Niagara system, create a new system, I can choose what I want to do. So if I want a completely empty system, I want to start from scratch, I have no idea how I'm going to explore, I can do that one. I can do it as a system from a template. So we've got a few that come with Niagara by default. Or I can create one from existing ones. So if I wanted to, I could say, hey, I want one system that includes these, what, 4 or 5 emitters. So I could really quickly just kind of pull my pieces back together and start making changes and have them all work. So there's a lot that can be done just when you start from scratch. So let's start with just a radial burst. Give it a default name. And immediately, right, it has some complex behavior. Spacebar, by the way.
Spacebar.
Yeah, I was actually hitting question marks. Like, no, wait, it's spacebar. And all this did was find existing emitters that were created and just create a new system and drop them in. The behavior between, you can create your own templates. So say you have something like a game that relies really heavily on sparks, right? You have a really well-crafted, this is what bullets look like as they spark off metal, off glass, whatever. When you want to create a new one, you don't have to create from scratch. You don't have to duplicate. You can literally just leverage, okay, make this a template, and now every VFX artist who sits down can go create a template based on my project sparks and tune it. So it becomes much easier to inform your team how to use the system, to set up presets and prefabs, to let them create things really quickly, and to not have accidental performance costs. You know, oh look, I created this great new spark and don't realize, you know, you're creating 50,000 particles that you don't really need, or it's doing something really expensive that you didn't realize was still in there. This lets us kind of set things up, expose them to user in a really convenient way where you can select what you want, and then again, I can make any of the emitters that I create through this process as templates. So whatever I end up doing, whether it's dropping in some simple little thing that just creates random colors as pixels like fire, or even things like simple little footstep puffs. So this is literally just, get it away. So this is just a little puff of smoke that shows up under your feet when your player walks, right? So I can create this and say, I've got 50 different materials that I need this to look right on, right? Stone, dirt, concrete, grass, whatever. This is the easy way to start that. I can just take this, and it's literally 2 little smoke puffs. I can add another one. And now I immediately have the same thing, but with this directional burst. And then I can start going into the directional burst and say, well, its lifetime is 0.8 to 1.5. Let's link that to age is probably not the best thing to do this to, but system age. Yeah, it'll kill them off completely because the system age is already and set a local value and just say everything just comes 1. So, but again, we can go down and start doing like drag. The amount of drag is based off of the particle's age. So now as the particles get older, they will actually drag more. Now the values for here are 0 to 1. So what I could do is I could make a new expression, and I could actually write particles time dot age times 5. Well, I think I need.
So you're just writing the formula, right in the.
Yeah. Unfortunately, I don't remember. I don't write code. I want that clearly understood. I am the world's worst programmer when it comes to physically writing. I didn't learn coding syntax. I didn't take any engineering or programming classes. Everything I know about engineering and programming is from the art side, trying to figure things out over the course of many projects. So there's a lot there to unpack about how I got to where I am in my career. But
there's documentation.
Yeah. But yeah, so like I said, any value that you've created can be exposed. So I can say the lifetime of a particle, or the particle initial lifetime. So now my drag is based off of the particle's initial lifetime. So if I set it to 50, the particles are going to live forever, but they also have a ridiculously high drag. So they're going to live for 50 seconds, but they're not going to be able to move because their drag is equivalently high.
Right.
So again, I can set this back to 5, and now you can see they kind of behave like they used to, but still damped. So again, linked inputs make it really convenient to say these two things are proportional to one another, or this thing is directly affected by something else. And then on top of that, over here we have the system itself. And here's where it gets fun, because you can start adding parameters. So I can make my own Boolean and name it my bool. Would help if I didn't give it bad characters there. So now I have my bool. So anywhere that a Boolean would be valid, let's see if we can find somewhere. So I can just type my bool, and I could replace whether or not that sample scale factor is with my bool. Now, this Boolean that I've created, because this is at the system level, that will show up when I place this in the world.
Okay.
And that team value, if I go back and look at the team object, you'll see I've got that set up in a very similar way. So I have a user parameter, which is named team select. And then my team select uses that for, here's where that bool is at. So that bool, which shows up on my object in the world because of that value, right here, that's how that's hooked up. So it exists in the system settings as a local value that can be set by the user. And that can be done through blueprints, that can be done placed in the world, it can be done based off of game logic. You can say, hey, look, temperatures in the game have exceeded a certain value, so let's flip that bool, and now every time you spawn a particle system with paper, it's on fire. Things like that.
Yeah.
You can have everything be data driven, way more so than it was possible with Cascade, because while Cascade could do these things independently, it didn't have that concept of linked behaviors. So every time we had to, like, one particle does something to another, that had to rely on the event system, which is, oh, a particle died or was born, and then we can do something. And that's not always what you want, because you may not be killing your particles. It may be just some condition based off of the game. I'm running over a certain speed, so now my particles are more blurred, things like that. And that's true across all sorts of cases here. So again, I've got there. So you can see these particle systems both have the trails behind them, but the Niagara one has a much better robust spawn by unit. So here's the trails. Spawn rate and spawn per unit are driven here, and that's what gives me the particle spawn as you drag through the world. And I've found that the behavior is just is cleaner with Niagara's implementation. But if you go through here, you can see most of what I set is just the base default parameters, just like you would in Cascade. Create a template, whether it's a spray or a spark or explosion, and then just push and pull those values around. Where it starts to get more interesting is when you start to realize that you have way more access to forces. Things like being able to have curl noise, vortexes, things like that. Much easier to implement. And so that's how I start to get the better trail behind that wisps out a little more naturally. And then there's all sorts of things in here. For example, we talked a little bit about this before the stream. This project has a couple of little things that I've been kind of playing around with it for a while. And as I said, I'm going to give Victor the content, and you can package it up however you like. But there's a couple of things in here that I just enjoyed doing. One of them was this nice fireworks launcher. So if you open it up, it's got a few emitters, and I've actually categorized them.
Nice.
So this particular emitter leverages our event system quite a bit. So when the primary launch particles get spawned, it doesn't spawn very many of them. And that value is set to a launch count. So again, just like in the other particle systems, I've got user parameters set up for the launch count, how many is it going to spawn, and the color that it's going to do when it spawns them. So that in the initialized particle is where all this is set up. So here's the launcher color, and then the actual spawn is how many.
Okay.
And then once this particle system dies, it's generating a death event. It's also generating a location event. That location event is per frame. So as the particle moves, I get its current location and can do whatever I want. And then when the particle dies, that's kind of the thresholding event. Something big has happened. Rather than just being I'm moving so kick off some sparks, something big has happened. So to look back at the actual system itself, if I go down to its properties, I haven't set anything up, so I'll just set a nice bright color. We'll even amplify it a bit, and then we'll give it a launch count of 2. So again, this is a single emitter that's handling all of the launch behavior. Creating the particles and doing all of the primary explosion, the flash, the sparkles that are coming off, and the displacement over time. You can see as the particles start to die, they start to wisp.
Yeah.
All I did was in the settings for the explosion happens here. There's forces that are being applied. Those forces can be modulated based on the actual age. So here, as the particle gets older, it just gets more and more influence from that force. So that force is really, it's always there. It's just doing nothing, and then has more of an effect, so you see it start to kick in the wispy look. So again, I'm very happy with the way
it looks great.
Yeah, the forces particularly I've been having a lot of fun with. They give a lot of life and kind of coherence to particle system. You get more of that fluid vortex kind of swirly viscosity feel, which I find is really important for big systems, because if you think of a really big explosion, the explosion's force itself is acting on everything around it, right? It's not just a bunch of discrete things that appear and then go moving away. It's this force wave is causing things to move, and being able to kind of invoke things and have them interrelated, I find is really, really interesting and compelling. So I'm very much enjoying kind of playing around with that and seeing how you can have like, oh look, I put this here, and then a blueprint is informing this, and then the player is driving this, and it's one system, right? It's just how many things are acting on that, and how well can it be informed as to how to react to those. And
then you work with the designer, either they expose parameter that they would like your particles to be driven from, or you do the opposite, where you give them, hey, I set this up here for you. You can now drive this, play around with it.
Yep, exactly.
Play around with it. Is that what VFX artists do all day?
You'd be surprised how much of what I've absolutely shipped, like is in games, is a result of like 10:30 at night. Oh, I wonder what happens if oh, that's cool. Okay, that's cool. I gotta remember that tomorrow.
Yeah.
So that kind of thing absolutely informs it. There's I can't tell you how many things I've come up with just playing around and going, all right, what happens if I plug these two things that should never work together? Okay, it didn't work, but there was something kind of cool there for just a second. Let me see if I can tease that apart and figure that out. So yeah, there's a lot here to unpack. And again, like I said, and I didn't show the impacts or anything too much. So it's pretty much just a flash that's oriented to a particular surface. So wherever your wall hit, it comes off that wall. And then the muzzle flash is also extremely simple. And again, you can see like a lot of these sub-emitters are coming from the same places. Impact Sparks is in both that and Fusion Bolt. It's because once you have that library of a few simple systems, you understand how they work, dropping that in and going, okay, now turn it 90 degrees or expand it or increase the velocity or make it more fiery instead of liquidy, it gives you that leg up on building new content really quickly. Well, you start to really go, I'll just drag this in instead of I'll rebuild this emitter inside of this system because I think it looks good.
Would you consider the workflow similar to material functions?
Very much so. the difference being material functions are still, they're kind of dropped in and compiled in place. You have to fix you have to make sure that you satisfy the constraints for that function. While you can have interrelated behavior like that because of like events and things like that, the particle systems are much more standalone because they're usually functional when you drop them in, and then you're kind of biasing them to do what you want. Material functions require a lot more like, this is going to do something for me once I have figured out everything that needs to be hooked up and satisfied all its requirements. So while the leveraging existing work and the iteration time is way improved because of that, the way sub-emitters or emitters are used in Niagara is even better than that in a lot of cases, because they really can. They can react. It can be the system can be set up in such a way that it just links to things. And so I can go, oh, okay, my team color, or I can write a new module, which is what that team color module is, and then share that to other people. So now I can make utility stuff that it's not even a particle system. It's literally just, oh, here's a node that does something really convenient, and oh, if you hook it up like this, it does this as well. That kind of thing is going to be critical for teams, especially the ability to iterate quickly, to build a very large effects library with a small amount of work, right? I can now create this or my main fusion bolt here as a template. And then, like, if I'm making a project that has like 100 different bolts like that, that means that my effects artist can now start right there and only make the changes necessary to differentiate, instead of having to like rebuild the wheel every single time.
I like your little particle fire.
Oh, thank you. Yeah, I had distortion in it as well, but it didn't look as nice. There's something about a clean, simple.
Yeah.
It's not that complicated an effect, but I do find it pleasing myself.
Maybe for next year's Yule log
there
video.
There you go. Yeah, we'll do something extremely different. So yeah, again, the particle systems, I've got equivalent ones from Cascade, so you can see kind of how it would have been built before, and then the same thing in Niagara.
Yeah, and we should iterate that. As soon as we're done with the stream here, I'm going to take the projects from Alan, and I'll put it up on the forum announcement post so you can go download it.
Excellent. And again, you can have them both up side by side so you can compare behaviors. And for those of you that have used Niagara before, I think 423 or 424, the kind of stack look for here is a more recent improvement to Niagara, and I found it actually makes it much more legible, rather than having a large kind of pre-authored frame with a bunch of them stacked in. Being able to go, you know what, I just don't want to look at this right now. I'm only concerned about these, and then bring it back in. This starts to bring some of the best parts of Blueprint in the organization and kind of data management layout.
And I saw you can add comments.
Exactly. Yeah. It's way like, especially the launcher is a good example. Like being able to just go, oh look, primary launch explosions, secondary sparkles. I don't have to go and look, okay, which one is this? I don't have to start trying to break it out here. I just have it as a nice overview. So yeah, it's the tool overall is become very, very robust, and the kind of paradigm for how to build and use the particle systems, in my opinion, is superior to Cascade. And while Cascade is certainly still capable of making amazing effects, Niagara has a lot of the core functionality already built in that's going to allow you to do things that Cascade just couldn't do without a lot more engineering work.
Yeah,
so
definitely. I'm foreseeing a lot less individual particle systems existing.
Oh, absolutely.
Yeah.
It's going to become kind of the Lego method of building, right? I've got a bunch of pieces that work independently, but the sum of them can be greater than the individuals, because you can now make something in 4 or 5 motions, so to speak, that does a complete effect, whereas before it would have been a lot more finagling and nuancing. And just to answer something I've been asked a few times, there is no current tool for converting Cascade to Niagara. It's something that we are aware of the desire for, but there's still enough development work being done in Niagara that it's not It doesn't make sense to do it yet. It is on our mind as to how and when to do it, and when we have a more concrete decision as to what that looks like, we will inform people.
Sounds good. Ready for some questions?
Yes, please.
All right. So that was my first question. You already answered that one.
Yeah, I like I said, I've gotten that one quite a bit.
What is the intended way to call looping VFX? Currently, I'm overriding max loop count from a bool, but I get warnings.
That's a good question. I don't actually know, because most of the stuff that I've done has been kind of ongoing life rather than looping. I haven't actually gone in and set that yet, so
okay.
I just don't know.
We'll see if maybe someone else might be able to answer that one. How do I make LODs in Niagara?
I have no idea.
Should we try to figure it out?
Yeah, so I think I've got the wrong system selected anyway. Yeah, LODs, again, it's not something I've created locally myself. So again, I don't know.
Next question. We got plenty, so
Okay.
Don't worry about them. I'm sure there will be a couple.
I'm sure there's going to be a lot of them that's like, that's a good question. I don't
know. Will Niagara be in its final release date in 4.25?
Final? No. Again,
will
because
it ever?
I mean, Cascade is not quite final, right? It's we'll still fix a bug if it's critical and things like that. So, no, I expect Niagara's development to be ongoing for quite a long time. If you look at the development of any tool, our typical path is experimental and then kind of open and everybody can see it, but it doesn't replace its previous incarnation like Sequencer and Matinee. And then the two projects live together for a very, very long time while they are both maintained and being used, and then eventually the primary development work and ongoing use switches to the new one, and the old one stays around for quite a long time. So while we are pushing Niagara to be completely feature complete and we're already using it in projects, I can foresee a ton of development work coming down the pipe, just as we respond to feature requests of our own and fix issues and come up with new things we want to do.
Just like any other.
Just like every other tool in the suite, yeah.
Yeah. Let's see. This question is a little bit on the LOD as well. Will Niagara have LOD support similar to Cascade without having to use blueprints?
Yes, though the intent, and I'm probably going to get corrected on this, is that Niagara's system is more robust in that you can set, instead of just being able to like bias the amount of particles that get spawned or size, it's a more fluid system. But again, I haven't used it enough to answer in depth. And it won't require blueprints to fire. It'll be inherent to the system.
Is it possible to spawn particles off the location of another emitter's particle inside the same system?
Yes, that's actually what the fireworks launcher is doing. So there's actually two different things happening. When the firework launches, it's generating its location. So there's that core one, the core spark that shoots up. It says, every time I move, inform anything else that's listening of my new location. And then there's the death event that says, when I die, tell everything that cares that I died in my position. So the spark trail here is looking for particles that have been spawned in this source. So that this is where I'm linking where it's coming from. So the launcher has a location event. That's the one I care about.
By names there, yeah.
Yeah, exactly. So my launcher and then the primary burst, or don't do anything at all. So it receives the location event. This gives it properties for like how much of its velocity to inherit, things like that. And then I can also bias after that. So this is exactly that. This particle in the launcher system is informing Sparkle Trail where it is, allowing Sparkle Trail to spawn from that location, and then when it dies, it cleans itself up. It also creates the core flash, which is the kind of bright white flash that happens as if the detonation had occurred, and also when the death event occurs for the launcher, I also do the secondary sparks that go off. So all of that is literally just A happens and tells everywhere it is, and then it dies, and that creates B, which creates C when they die. So literally it's A hands off its information to B, which then go, oh, I know what to do with this. And then until it's done, it hands this information off and go, oh, okay, I know what to do with that. So it's literally exactly that. One particle system is informing everything else what to do or where it is, and everything else decides on their own terms how to handle that.
Awesome. Can particle in Niagara system be used as a character mesh? Now, I believe the question is, he says, I want to control particles as a character third-person shooter in the game.
So Niagara has this concept of data interfaces, which is how is Niagara going to be informed about the data from a different kind of object? One of those data interfaces is for skeletal meshes. So and you can look in some of the sample content. You can get a skeletal mesh's data, whether you're talking about the actual triangles and surfaces or just the vertices, and use that in Niagara as info. And again, because we're talking about literally okay, I just want to grab like this data point and use it, like emitter.age or whatever, the data interface hands over that same data set. So I can either write a new module that says, here's how I'm going to handle like for these particular bones, or if I just want the whole body or whatever, we can absolutely spawn from those surfaces. And as you walk through, have them trail behind you or stick to you or whatever. There's a couple of examples of our mannequin running, and then there's a second. Him running is all particles. He's actually not visible, but it's particles that map to his texture UV. So if I spawn here, I know that on his UV map, I hit this location. We then use that same texture in the particle and say, if you hit this UV space, offset your rendering to that point in the UV space. So you essentially render a chip particle of the same diffuse texture, and then you can move that around. So you can say, I look kind of like a pixelated version of myself, because that's where I'm sampling for the UV coordinates, and as long as the textures line up, it looks like me, and then the other systems can come to play and affect those particles.
And these samples exist in our content examples, right?
In content examples, Niagara, there's examples of skeletal meshes being used as the source location, and also other things like expressions being used to drive all behavior and more.
And you can download that from the Learn tab in the launcher. It's right there. It's actually quite interesting just to have a look, even though you don't really know what
there's tons of things in there.
There's a lot.
Well, lots more than you would expect from looking at it. In particular, make sure to look at the maps, because for Niagara, there's a Niagara map. Open that, and there's quite a bit of information in there. And of course, there's maps for most of the other features in the engine at this point, or at least the design, tech art kind of things.
Can you still make the particle system have a vector parameter that you can access in blueprints?
Yeah, absolutely. So just like I have those user parameters, like user count, launch count, things like that. That launcher color is a vector parameter. In blueprints, that would be just an exposed value that I could push into it. So just like I could have my blueprint set the color for the launcher, or I can set it manually. To the engine, it's just a point of data that can be interfaced with.
Let's see. Can I create my own Niagara system templates?
Yes. So one of the things that you can do, I'm not sure if you can do it right from here, but yeah, there is a way to create new Niagara templates. I haven't done it myself, but I say that I did it by accident one time. I don't remember exactly how I did it. But yeah, it is possible to basically create a particle system, and then that becomes a template that you can offer to your artists or designers after that point.
Apparently, LOD is in the scalability pull-down menu.
LOD is in the scalability pull-down, which I would have to find that as well.
Doing it live.
Yeah, that's the case. Anyway.
It's in there.
I'm sure it is somewhere.
If you're looking for it, I'm sure it should be marked in our documentation. Let's see here. How's Niagara for VR development?
It's like anything else for VR development. You have to be very aware of your performance characteristics. Niagara doesn't do anything that would be explicitly a problem, but like anything else, if you put 10,000 particles into your scene and there's overdraw and lighting, you're just going to have problems rendering that at high frame rate on 2 cameras like you need for VR. So there's nothing inherent to Niagara that says you shouldn't or can't use it for VR. You just have to make the same intelligent content choices that you would if you were building with Cascade.
Yeah, essentially no difference between Cascade.
Yeah, I mean, while there are definitely different performance characteristics between the 2 systems, at that level, you really are talking about more art and content choices and kind of the brute force phase of scalability and just being careful with how your content and counts.
Can you please show us a sprite-based particle? That's pretty much what all these are, right?
While there are some mesh-based particles in the sample content, I didn't happen to use any for here. So if you notice, and I'm scrolling around to look, this icon means that it has a sprite renderer. I could easily add a mesh renderer and pick from a mesh. And then not that you're actually going to see anything. The mesh is part of the spark that goes up. But yeah, there are things that you can do inside of the mesh details to interact directly with the mesh. But as far as Niagara is concerned, it's creating a data set that you can then choose to render what you want at those endpoints. If you think of a point in space and you say this point in space has a mesh at that point, or a sprite, or the beginning of a ribbon, or something like that, that's literally how Niagara is deciding. You tell it what you want it to render. It handles figuring out where to put that.
Okay, it's nice how it's decoupled like that.
Very much so.
They're asking for a few common Cascade behaviors, such as color over life, size over life.
Sure. So, I mean, just right here, I have my launcher. The initial color is set when we initialize the particle, but that is literally the color it has when it spawns. The way Niagara works is very linear in terms of creating a particle and then simulating it. So we have the emitter spawn, which is when this entire particle system is created in the world, whether that's the artist dropping it in or I pull a trigger and a blueprint spawns it. There's nothing being set up here. The emitter update is the entire system's lifetime, or ticking, essentially. And that again, it has nothing to do with the particles themselves. This is my emitter tracking its own. So if I want to say have my emitter spawn particles for 2 seconds, I could track the emitter age in here and then just shut it off at that point. The particles then would never spawn because the emitter, that their owner got shut down, right? The car is not moving, so the passengers aren't going anywhere. Particle spawn is where the particle has been created, but it's not doing anything yet. And that's where we do things like pack the payload, where its initial color, its initial velocity, and then we simulate. And after that point is when particle update kicks in. So particle spawn, you shouldn't expect anything to happen over lifetime, because it's literally just the frame that the particle enters existence. So that's why it's safe to set the color, and then inside of my particle update, we have scale color, and this is where we can set the curve for, in this case, alpha. Now that's a float from curve, so it gives you like all these controls. My scale color, because I'm only modifying alpha in this particular one, is just pegged at 1. If I were to do scale vector by curve, I get the same kind of curve editor, and I'm not in a great place because this is the core spark. You're not going to see much, but I can now go in and set that curve, so my particle can now change color over time. but I'm probably, in doing this, I'm only scaling that color value, so if I happen to there. So now I have some ridiculous value being passed in for just the red. So yeah, there'll be it's a little brighter because the red has been scaled up a bit. But that is literally if I wanted to scale the color, if I wanted to set them initially and do them over time, you could do it the same way. Color over curve, plot your curve. The curve index, meaning how do I retrieve that value, is the normalized age of the particle, meaning 0 to 1, 0 at birth, 1 at death. If the particle is 3/4 of the way through, then at 0.75 on this curve would be what it would return as, here's my current color. So this is literally color over life because it's color, and then the index is the normalized age, which is over life.
And if you would enable that, what is each individual?
The checkboxes is just whether or not that module is active.
Module, and module is the terminology used for each of the components.
Right, and those can be either ones that our engineering staff created here, or it could also be ones that, like in this case, the FXM team, that's a module I created, the one I opened earlier. I didn't write any code. I literally just, like I would a blueprint, okay, I want to wire this, break it apart, wire these together, put it back in, cool, it works. And then it's just satisfying the constraint of making sure that you know that it's exposed Boolean is something that the player can see or the user can see. And I've gone over here to the parameter stack a couple times. This will actually show you all of the kind of data objects that are being created and tracked for the payload for this particular system. So I can see, like, you know, the output for the normalized fall-off module is a float, and I could use that somehow. If it were data that I was interested in, this would let me see it. I could even drag it into the appropriate place if there was one. I don't see anything in particular over here. Yeah, so when I start dragging, it shows me what I could just drop this in. And you can see it's changed the gap correction amount to that value. So it really does look at data as just information. It's not, oh, that's this thing's, it owns it, I can't touch it, or I don't know what to do. It's a float, but I don't recognize it. It doesn't care. Literally just go, oh, I want to use this, and I'm going to coerce A with B, and then I'm going to plug in some C, and look, I get Q.
Yeah.
Awesome. It really does mean that you're no longer constrained to just doing stack A. Okay, that does one part. Stack B does another. You can now have them be informed and have intelligent behavior happening because of that.
Do you know what the numbers next to the variables
Number
mean?
of places they're used.
Okay, in the entire system.
Yeah, so like if I go up to my user ones, like it's used twice for the launch count and 5 times for the color. Yeah.
Maybe that will do something.
I think the intention is that it'll eventually take you to
and show you.
I don't think it does it yet, but yeah. So it's very very built to be communicative, if that makes sense. Everything is designed to understand this is just a value of type float or a value of type vector or whatever. If you hand it something and the data is present, it will work on it. If it's not present yet, you might get a simulation error or behavior that you didn't expect. But it really does make it very compelling when you can go, I'm just going to like grab the location of this and just piggyback off, and then I'm going to divert off to the side, so you can get all sorts of really cool kind of inherited and kind of recursive behavior. I've seen some absolutely amazing things that people have done on like Twitter, where it's very procedural. Like they're literally using the expressions to write code that does like all of this complex like Mandelbrot, and just the math is staggering. But the fact that these people are figuring out how to do that in an hour or two because they can just, oh, I know how to write HLSL, I understand how the variables are stored, let's start using this as you know, a formula and look, it does the cool things to the particles.
Yeah. Do you know if Niagara is currently supported on Android?
I don't know. I believe so.
I think so.
I haven't worked on an Android project in like 2 years, so it wouldn't be something that would cross my desk as making sure it's compatible.
It will.
But I'm almost positive it's functional on Android. I just don't know if there's any caveats in terms of supported feature sets or expected hardware platform it should be used on.
Yep. It will support
all
platforms.
Exactly. But I'm only saying I don't currently know the state of it.
Yeah.
I'm being careful, being very careful.
It's good sometimes. Is Niagara more performant than Cascade for the same CPU effect?
In most cases, yes. It does a much more efficient job of creating and spawning particles because of the amount of kind of data transparency. There are other overheads that are involved, but the base performance of creating the sprite, assuming it's a sprite, just I'm going to create X number of sprites in this many milliseconds and then let them simulate. Niagara has a much better archetype and design philosophy for all of that. So it does. It's just a more efficient way of handling everything to do with particles, not just a better tool. It spawns them more efficiently. It can simulate many more particles in less time with better fidelity. But like any other tool, there's always things that we're working on and ongoing development.
Still zeros and ones.
Mm-hmm. It's still zeros and ones and very large numbers of lines of code.
Yeah.
Again, not a programmer. Don't want to be a programmer. I'm avoiding programming with everything I have, but I do have some understanding of how difficult it is, which is why I avoid it.
Yep. Is it possible to send arrays of data from Blueprint into Niagara?
That's an excellent question. Probably using a data interface.
Okay.
That's right. The idea. The idea behind a data interface is here's a way of packaging complex data and exposing it to Niagara in a way that both systems understand well. So we've got data interfaces for different types of like bringing stuff through Houdini into Niagara for having like static mesh data, for skeletal mesh data. That's extensible as well. So if you have like a new type of object, like whether it's something that like you're importing from a third-party package that's new, or if it's just something that is unique to you, you could write a data interface for it, choose what parts of it to expose to Niagara, and then allow Niagara to utilize that.
And the core of that, sort of the core of the data interface, it's just completely agnostic, right? Like you can take a MIDI keyboard or anything you can think of that can somehow pass data.
And essentially it's just a way of presenting that data to Niagara in a way that it understands. So whether that's here is a bone position or a curved surface evaluation, or here's the point at which the simulated physics strain exceeded a certain value. So, okay, you broke, so I should spawn particles where you broke to get the dust of this skeletal event. So it's things like that. It's the ability to look at it as what part of this data tells me what I need to know, and then using that in Niagara in an effective way.
Does Niagara support sprite trimming like Cascade did to cut down on overdraw?
I know what you're talking about. It's the
where you cut the
it's making like an octagon instead of a quad or I don't know. I don't think so. But I very, very likely could be wrong. That's one of those. It was a bit of a late addition to Cascade, and then it became kind of automatic. So from the art side, it wasn't something that we had to explicitly worry about, as long as you satisfied the right. There was a field where you gave it the same texture, and it would figure out the correct trimming. But I haven't done that with Niagara, so I'm not sure if that's been implemented or not yet.
We will see. Is it possible to change the timeline during playback? For example, jump from 10 seconds to 60 seconds if a particle needs to die sooner.
As in skip over? No, the timeline is linear. What you could do is you could have an event that evaluated it, and you could just turn off particle spawning or something like that. You could write your own script that says spawn unless I tell you not to, and then that condition could be driven by you, or it can be driven by something else. It might be possible from blueprints to explicitly set the position and time, but that would be kind of an odd, like, back end way of kind of doing it. My guess is you could probably use a blueprint to jump the playback time from A to B, but I'm not sure if the system would understand that as a cut, or if it would try to spawn everything in that frame between those times.
Can you spawn skeletal meshes as particles?
No, not currently. If you look, the renderers that are available, the mesh renderer is static only, so it doesn't give you the option of skeletal meshes. That said, the intention is that this, like choosing sprite render or mesh render, it's a module. It's something that your team could write just that, and all of Niagara would just understand at that point, right? Here's how to work with this asset when you're spawn, and everything else. The rest of Niagara just goes, okay, you've told me how to do it, and now I understand.
Vaguely remember Wyeth mentioning something about that last year, but I could be wrong. What are some limitations to deterministic particles?
So deterministic particles is something that our cinematics team uses more often than I do, because it gives them the ability to scrub back and forth. I don't know. Again, that's a very kind of limited use case, at least in our methodology. Most of the time when we're doing determination, it's because we are doing it as part of a cinematic, and we want to make sure that, when you go through dailies, you're not, but it's completely different every time, and that makes it very hard to narrow in. But for most things, for most like gameplay uses, we don't care that much about determinism.
Could be for, say, a cinematic event in the game where you want the explosion to always...
Right, you want the firework launcher is an excellent example, right? The sparks are going to go in some direction when they explode. If they do it differently every time, then there's no way you can go, I like that one, let's keep that. Determinism lets you go, okay, here's my random seed, here's what it looks like, cool, we like that, and we're just going to keep that unless somebody tells us to change it.
I ran into this problem in Cascade. Is Niagara capable of randomly uniform scaling particles? Say your min scale is 111 and your max is 555. Can you get a random scale without deforming the object?
Yes, though I would probably do it by writing a module that read a single random scalar and then manually set that to be the XYZ scale for the object.
Okay.
Right? Which you could probably do that. There's probably a module already in Niagara that would let you do that. And that's one of those, like, there's plenty of things to find as you go through, like size. There's mesh size scale, sprite size scale. So there's no actual mesh being spawned, but I could change this into a curve, make it a float, lock the axes, or I could just write an all-new module that did this explicitly. So I'm not positive that there's a pre-rolled way of doing that, but I don't think it would be difficult to pull it off with a little bit of work. And the wonderful thing about that is if you do write it as a module, you can use it with every other thing instead of just figuring out how to fix it in that one event or in that one particle system. It's like, oh, here's a module that just does, uniform random mesh scaling. Cool.
Does Niagara make it easier to get information from scene, like projectile impact normal or surface type where impact happens?
That's not on Niagara. That's on the blueprint interface between the event that occurred in the world and what we pass into Niagara. Niagara at that point is pretty agnostic. You can pass in that data, but you're probably going to pass it in as a I'm just filling in vector parameters that I've exposed in Niagara. And then, I mean, we already have like a struct that gets generated when you do a trace and hit something that returns things like surface normal, hit vector, things like that. So you could easily figure out how to pass that data in and use it. But there's no like blueprint interface between a trace in the world and how Niagara is going to react. It's literally just the same data we'd pass in. You just choose whether or not you want to use that data. And again, that's an ongoing thing that I keep finding myself saying, is that you really can treat data in Niagara a little more agnostically than you could in any of our other tools, since you can just go, look, I can hook this up to this, and this up to this, and this up to this, and now when this one thing changes, these 5 things all change simultaneously. So it really is kind of changing the way you think about the data, instead of it being like, this module does this, and then this one does. It's more like, this module links into the flow of everything that's happening, and if I need to, I can adjust how the data flows through that module.
The next question was in the same line, which was, if you change the name of a user value in the blueprint, is the emitter updated automatically? They don't have that.
Yeah, the blueprint wouldn't be. The blueprint wouldn't define what's in Niagara. What you would see is this system has variables that I can talk to. Just like, you know, and if I have a static mesh and I decide I want to change, you know, the size of it or something else, I can just drag off of it and go, you know, set transform and get to that.
Yeah, where you declare those properties.
Yeah, they're declared in the asset, which means you would declare your variables, your user variables, inside of Niagara, and then in Blueprint you choose when to pass things into that, rather than driving or creating them through a blueprint. I hope that satisfied the question.
I think so. It's good that we're touching a little bit on the sort of philosophy as well.
Yeah, there's definitely a difference in philosophy between Niagara and Cascade, and I think the kind of free-flowing approach to data is a big part of it.
Is it possible to use Niagara to create a swarm of meshes, like asteroids, that the player can blast?
I don't think they can have collision, so probably not. What you'd probably do is have a very simple asteroid class of blueprint that, when shot, would spawn Niagara particles, and potentially, you know, do something where it looks to see what the mesh was. If the mesh is this, then it uses this Niagara system, or changes the like the mesh particle to be a different mesh, right? Oh, I shot a brown asteroid instead of a gray one, so make sure that the chunks that come off are appropriately colored.
However, the Niagara system itself can trigger events based on the particle collisions within it, right?
I'm not sure whether or not you can pass those events out in a way that blueprints would fire.
not talking about blueprints.
But yeah, internally, yes.
Yeah.
I could absolutely set up an animation, a simulation of, you know, like just like with the firework launcher, where this hit this, it overlap. These two particles are overlapping, so something is true. So now we go, okay, kill them. Now that we have a death event, let's spawn this. Now that we have a death event off of those, so you could do the bolt hits rock, rock splits, and then breaks up into more pieces, all completely inside of Niagara. But you'd have issues with replication, with collision, things like that. So while a lot of those would be possible completely in the particle system, we would still likely build it as a shared event between a couple of different systems, so that, again, like I said, scoring, replication, collision are updated appropriately.
Is there any sort of practice that should be avoided in order to work with Niagara?
Nothing explicit that I've run into. I mean, it's really easy because the tool is new, and there's, I would say the thing that I've done most is accidentally scrolling up to really large values, like going to my particle spawn and accidentally clicking like way up. There's things like Cascade has had over the years limits applied to certain scroll bars, so that the values don't go very far, and that hasn't really been done. It's one of those like little polished things that just hasn't been applied. So it's knowing that like the spawn count here, if I just set this to be a local value, which would be just a float, as I scrub a little bit, it goes up. But if I end up in like the 500s range, I'm spawning a lot of particles that are doing a lot more secondary stuff. So there's definitely things where it's easy to, I changed it's no longer driven by the user parameter, so it's just going to go with however many I define. So yeah, we can get some pretty, but you know, for all that I am spawning 25 explosions with all of their secondary particles and stuff like that, I think we're actually doing pretty well.
Simulation is still running.
So yeah, that's quite a few particles being spawned. You can actually see the count over here for, so you can see it gets up to about 3,000 particles while that's alive. And then the burst will have a few as well. There we go.
Oh yeah, there.
So the secondary sparkles, that is the that's that part. That's all the little ones after. So yeah, the fact that that one hits the almost 60,000 on top of a few thousand for others. Yeah. So you can see why the screen fills up pretty well. But again, that could be driven by a blueprint event, that could be driven by just the player entering a room, or just some constraint that Niagara imposed on itself. I dragged it in and over, because you can have random spawn behavior, so you can say, I could literally go put in a chance, like I could write a module that says, okay, there's a 50-50 chance you're going to spawn 1,000 particles. Otherwise, use your normal spawn rate, but every now and then, I want you to do something explicit. And that's the kind of thing you could never have done in Cascade. You'd have to have like a blueprint class that did that explicitly and then chose between different particles to spawn. Now, that kind of logic can just be handled inside the system in a very graceful way and not require this, monolithic, here's a blueprint with all of that entails, and then I've got this logic in there that does things with different particle systems, and then I finally have something to render. I can just open up that data flow, modify the flow at that point, and then let everything kind of continue on gracefully from there.
And you can set that up in hindsight as well, which is nice.
And again, when you do stuff like that and you realize, oh, this is a really useful thing, writing it as a module means that it's shareable. It means that it works with other people's systems. It means that it's a very easy, transportable work that you can have done and leverage later on.
What is the one question you wish people would ask but haven't, and what's the answer?
Okay, for Niagara in general, I'm looking forward to seeing how people interact with Niagara, sequencer, and blueprints in full projects. That's the point at which I think things start to get really interesting, because now you have things that can be spawned dynamically, you have things that can be authored to interact well together, you can have physics, like you start getting really, really complicated systems, really interesting things happening. I mean, if you watch our chaos demo, all the robot blowing up the building, it's a mix of Niagara and chaos and all this stuff. And that's where I start to see the really cool stuff happening, and I'm looking forward to people diving into that deeply. It's not quite, it's one of those, if you actually ask the question, it's way too big a box to get into. But it's kind of like the promise of what that is going to evolve. That's where I think things are really, really interesting.
That's exciting.
Yeah.
Yeah. And this has been interesting. Let's see. Oh, there were a few more questions came in. Let's see. Is there any way to override light particle render settings with a script?
As in, my particles are spawning. There's one of the other render styles is light, which literally is spawning. If you're familiar with it in Cascade, it was if that was on, a percentage of the particle spawned would have cheap dynamic lights applied to them. It's the same idea. I don't know how much is actually exposed, though, again, I could very easily, if something wasn't natively exposed here, the bindings are here, so I can change some things, but you notice that like these values are not editable in terms of what class of value. So my guess is you could easily drive the bindings, but you couldn't drive these values.
Okay.
Would be my guess, just based on the way they're formatted. So you would either need to change the bindings so that you can, which is doable down there, but that only gives you limited window into those properties, or you could write your own renderer for those that had the interactions that you needed exposed. Again, the whole idea is that rather than it being like a monolithic, here's the tool and just use it, its modules are meant to be extended and expanded and customized.
Someone in chat was wondering if you can create a mesh shape of particles and interact with it. For example, the letter A made out of many spheres and use radial force on it.
Yeah.
It's the same way.
Yeah, it would literally, again, I use a data interface to use a static mesh as the spawning location. Mesh particles instead of sprites for the spheres. So now you've got your shape of an A. And then just like, you can actually see the forces being applied as the particles spawn and then die. You see that kind of settle out. It's the exact same, it's a force. It would be applied on the particle in the exact same way. In a very real sense, Niagara has no idea that there are particles, because all it's doing is saying, you wanted the simulation result, what do you want me to do with it? And then you drop a renderer on top of that, and that says, okay, that point and that payload, here's how to represent it visually. If it's a mesh, if it's a sprite, if it's a light, if it's ribbons are a little different because it does, particles can either be like linearly enumerated, meaning 1, 2, 3, 4, and then we can have effects that know that. Like a ribbon is literally looking at the sequential particles and creating mesh between them. That is a specific one, but in terms of sprites, meshes, lights, it very much is just I'm doing what you asked me to do. I have all these points in space, and you told me to render these sprites on them. Beyond that, or meshes, or whatever. Beyond that, it's agnostic.
I just got reports that it is snowing outside, which means that we
need
to go.
Home,
yeah,
because I live about 20 minutes away from here, and it's not the best drive.
So that's it. We were pretty much done with the questions, and so it's a good time to wrap up. Anyway, thank you, Alan, so much for coming on, going through Niagara. Hopefully, I'll have you on soon again.
Sounds good.
Alan always comes to me with like, "Hey, how about I bring this on the show?" And I'm like, "Yes, let's absolutely do that." Well,
unfortunately, like I said, over the last few months, I haven't been working in Niagara. I've been doing a lot more of the touch stuff, so I'm definitely very focused on one thing, and context switching can be challenging, but I very much enjoy it.
Yeah, so you never know when you see Alan again, but it will happen.
Yeah. I'll just be older, grayer, and a little less.
all of us.
I know.
Yeah, that's how it works.
Yeah.
Apparently how humans work. Next time on the live stream, how humans work.
How to watch us age in real time. Just watch the live stream.
Yep, there we go. Thanks everyone for tuning in today. Next week we will be talking about network fundamentals. I know that last week I said that that's what we were doing this week. That was me. Alan will not be here. No. We'll have Michael Prinke on the stream, one of our technical writers, and it's going to be a good stream. He's prepared some cool content for us, so I'm excited about that. Make sure you tune into our forums, Twitter, Discord, Facebook, everywhere we are for all news on Real. And make sure you use hashtags so that we can follow along and see what you guys are working on. If you're interested in submitting a countdown video for us, that's the first 5 minutes that we have in the stream, go ahead and take 30 minutes of development, capture that on your PC, and then speed it up to 5 minutes, send it to us with your logo for your project or your studio, whatever it might be, and then you might be one of our countdown videos that we keep in the loop. Make sure you let us know about your projects. I said that, but we frequently browse the forums as well as Discord, Twitter, etc. to find some spotlights for the week, and that's also the ones you see in our News and Community Spotlight segment in the beginning. I think with that said, we need to get out of here, so I'm going to say goodbye. I hope all of you have an amazing rest of your week, and until next time, bye-bye, everyone.